Welcome back to Think Thrice Problem Solving. Today we're going to be solving a fun trigonometric problem that is going to lead us to the complex number world. So we're going to have to deal with some imaginary numbers here. So our problem is sine of x is equal to 1. So I already gave you the hint that this involves complex numbers. So if you'd like to pause the video and give this a shot, go ahead and do so. Otherwise, we're going to jump straight into a solution. So I said we need to use complex numbers, and why is that? So let's investigate this problem. So first, let's treat this whole inside here as some other value. So for now, let's call this z. So my problem is essentially sine of z is equal to 1. So when is sine of z equal to 1? So that gives me that I know z is going to be equal to 90 degrees, or pi over 2. Or it could be pi over 2 plus pi over 2. It could be pi over 2 minus pi over 2. So, or minus 2 pi. So this could be plus or minus 2 pi times some numbers. So we're going to call n just some element of the integers. Okay, so n is an integer, so z is anything pi over 2 plus 2 pi n. Why is this a problem? Well, this is a problem because in the real world, so in real numbers, sorry about my e's, so we have sine of x is equal to some number. And whatever that's equal to, I know that it's going to be bounded by 1 and negative 1. So I said that we have a problem. So what's the problem? Well, the problem is pi over 2 is 3.14 divided by 2, which is approximately 1.57, which is greater than 1. So that doesn't work. If I add 2 pi, which is 6 to this, it's still going to be bigger than 1. If I subtract 2 pi from that, it's going to be less than negative 1. So essentially, in real numbers, there's no solution. Okay, so nice and quick, we've shown there's no solution. We can go about our business, walk out the door, and call it a day, or we can find what are our solutions in the complex plane. So let's look at this in the complex plane. So let's look at our problem again. So essentially what I've said now is this sine of x, which was our z, so z, which is sine of x, is going to be equal to pi over 2 plus 2 pi times n for some integer n. So this is essentially our new problem. And in order to move into complex plane, we're going to need to call on our exponential form of our sine function. So remember that e to the ix, and if you haven't learned this, this is something that you'll learn the first day basically in complex numbers. E to the x is cosine of x plus I sine of x. If you're interested, I showed this in another video using Taylor series. E to the negative ix is going to be equal to cosine of x, because cosine of negative x is equal to cosine of x. It's an even function. Minus I sine of x, because sine of x is an odd function. So what I notice that I can do here is I can subtract this function from the other one, and I'm going to get e to the ix minus e to the negative ix is equal to 2I sine of x, which tells me that I can rewrite sine of x as e to the ix minus e to the negative ix divided by 2I. Okay, so let's go ahead and do that. So my new problem is going to be e to the ix minus e to the negative ix divided by 2 is equal to pi over 2 plus 2 pi n. Sorry, this is 2I in the denominator. Okay, so let's multiply out that 2I, and I get e to the ix minus e to the negative ix is going to be equal to this whole thing times 2, so pi plus 4 pi n times I. So what I'm going to do now is I'm going to do a little substitution. So the first thing I'm going to do is I'm going to note that so I'm going to go ahead and do a little bit of work here. So let's go ahead and rewrite this. Let's multiply the whole thing by e to the ix. And we're going to get e to the 2ix minus 1 is equal to pi plus 4 pi n I times e to the ix. And I'm going to do a substitution at this point. I'm going to make y equal to e to the ix. So what does that give us? That gives us y squared minus 1 is equal to pi plus 4 pi n times iy. So this is just a little quadratic equation. It's 4 pi n I minus 1 is equal to 0. So this leaves us with, we can just, this is times y. So I can go ahead and solve this. So I know y is going to be equal to pi plus 4 pi n times I minus, plus or minus, the square root of b squared. So pi plus 4 pi n squared times I squared. So it's going to be negative pi plus 4 pi n squared minus 4 times AC, which is going to be plus 4. That's divided by 2a, so I'm going to have that divided by 2. Okay, so my next step in my solution here is, what was y? So y was e to the ix. So I'm saying e to the ix is then equal to this guy on the right, pi plus 4 pi n I, plus or minus the square root of negative pi plus 4 pi n squared plus 4 divided by 2. So if I take the natural log of both sides, then that's going to give me ix is equal to this whole guy. And then I can divide by I on both sides, and I end up with x is equal to 1 over I, which, remember, I can just multiply that by I, and that'll give me negative I. So that whole thing can be replaced with just negative I. So negative I times the natural log of pi plus 4 pi n I plus or minus the square root of negative pi plus 4 pi n squared plus 4 divided by 2. All right, so what does that tell us? Well, that tells us what our solution is. So our solution is this lovely equation over here. It is not unique. So we have an infinite number of solutions to this equation. And if we wanted to say, let's find a solution when n equals 0. So let's find our base solution for one of our branches. That's going to give us x is equal to negative I times the natural log. And then I'm going to have pi I plus or minus the square root of 4 minus pi squared divided by 2. And that would give me my solution when n equals 0, which is a little bit nicer. That is a super complex number. There's a lot of complex things happening in that equation. If we're actually looking for, I'm not going to simplify it, but if we did, we'd have to be careful, and we'd have to make sure that we're not violating any of our rules about log functions or anything in the complex plane. But I hope you enjoyed working through this problem. So kind of going a step deeper into the problem than just arbitrarily saying it's impossible, can't do it, because technically we can do it in certain situations. So if you enjoyed this video, please like and subscribe. If you have an idea for a different video, please submit to thinkthriceproblemsolving@gmail.com. And as you're working through problems, think once, think twice, and if you ever get stuck, think thrice.